The number of write data beats that the ASNE can send at once improves the performance by increasing the utilization efficiency of the downstream link. ASNI tower components use wormhole routing. In wormhole routing, when a component receives the header flit for a packet, it allocates the entire flit buffer for flits from that packet. It only makes the flit buffer available to the next packet when it has processed the last flit of the outstanding packet. The ASNI Write Data FIFO gathers incoming write data beats from the AXI requester. By gathering the write data beats for a transaction, the ASNI ensures that it sends as many flits as possible in a short duration. It therefore uses the downstream link more efficiently, reducing the number of cycles that the downstream flit buffer is allocated for the outstanding flit. We recommend that you size the ASNI Write Data FIFO based on two properties: the density of the data traffic through the ASNI and the size of write request flits. In other words, how many data beats are required to make a flit. The performance tool allows you to check if there were any stalls due to the write data FIFO being full. This can be found in the result statistics of the performance test case under the PMU category. There are no stalls in this case. For some other traffic case, if this was non-zero, then that suggests that increasing the write data FIFO depth may potentially avoid the stalls and improve the bandwidth. The average write data FIFO occupancy can be found under the occupancy category. We can modify the depth of write data FIFO from the canvas by selecting the complete interface and clicking on parameters under the property editor. The write data FIFO depth configuration parameter can be found under tracker depth. Based on our traffic, we will set this to 1 on all the ASNIs. Let's look at the area report. The total area for this configuration has reduced to 29,990. Let's run the same performance test case to make sure that we still meet our performance requirements after a series of modifications to our configuration. we can see that we still meet our performance requirements. So, just by correctly sizing ASNI tower configuration parameters based on our traffic, we were able to bring down the area count from 38,587 to 29,990. That is over 22% reduction in area without losing any performance.